You're welcome. Today we'll be discussing measures of association. And what we, when we discuss association between two categorical variables, then association between categorical variable and numerical variable, we talk about chi-square. Association between two categorical variables, chi-square, between categorical exposure and quantitative outcome is t-test or ANOVA. So we also talk about, association, degree of association between two numerical variables, that is correlation. When we talk about relationship between variables where we predict variable from others, we talk about regression. But here, when we talk about association using chi-square t-test, especially chi-square, you see that you cannot measure that association. It's not, you just say, oh, there's a statistically significant association or difference. You only p-value. P-value does not quantify the association. Though, if the p-value is very small, we say the probability is small, that the difference we have found is due to chance, is very small. But it doesn't, for the fact, if p-value is 0.02 and one that is 0.03, it doesn't mean, even though the one that is 0.02 is more significant on the value of the p-value, but it doesn't really mean that that association between the variable is heavier, is higher than the one that the p-value is less. So what I'm saying is that if okay, Dr. Awatu, I thought you are
sorry.
I didn't know that you are. Now, those aspects of statistics that quantify the association between categorical variables, we call them measures of association. You heard of relative risk odds ratio, then hazard ratio. That hazard ratio, we treat that under survival analysis. But here now we discuss relative risk and odds ratio. But before we go and talk about relative risk and odds ratio, let's talk about the risk and odds itself. Before we talk about the relative risk, let's talk about risk. Let's understand risk. Let's also understand odds before we talk about odds ratio. So we look at risk, odds. We now look at relative risk and odds ratio. Now, risk is probability. It's the same thing as probability. People think risk is all about bad thing. No, risk is just probability. But because for many times we've associated risk with something bad happening. That's why when you say risk, you are taking risk. You're like, if you drive in the night, you long journey in the night, you say, there's a risk, the risk or the probability of having accident or being attacked by hoodlums is higher than when you travel during the day. So they will not say, oh, you are taking risk. So if the probability of something good happening also is risk also, but risk doesn't have to be something bad. Risk is actually probability. It's another name for probability. So let's look at the risk of probability and odds. Risk is the probability that a particular event or outcome will happen over time. Example now, what is the probability that it will rain tomorrow? That is just risk. The risk that it will rain tomorrow. If it is 6 out of 10, it's 60%. Now, let's look at how risk and odds relate. We know that risk is as probability ranges from 0 to 1. The value of probability is from 0 to 1. It cannot be less than 0. That is, it cannot have negative value. It cannot be greater than 1. It cannot be 1 point anything greater than 1. So it's between 0 and 1, inclusive. So when the risk is zero, it means that it is certain that the event will not occur. When the risk is one, it is certain that the event will occur. So you know that when you express risk, you can express in decimal 0.1, 0.2. You can express in percentage. That is, if you multiply the decimal by 100, like 0.2 means 20%, 0.1 means 10%, 0.5 means 50%, 0.05 means 5%. So you just multiply the decimal by 100, it gives you the percentage. If you divide the percentage by 100, it gives the decimal. That is probability for you. Now, the other way around, odds ranging from a zero to infinity. For you to understand the concept of odds very well, let's see how does it relate to risk. Risk, odd is risk over 1 minus risk. That is, if risk is the probability of event happening, then 1 minus risk means the probability that event will not happen. For example, if the probability that it will rain tomorrow is 0.6, then the probability that it will not rain tomorrow is 0.4. But when you remove 0.6 from 1, it remains 0.4. So the 1 minus risk is the 0.4. It is the probability that event will not occur. So odds is the probability that event occur over the probability that the event will not occur. Can you see now? That is how many times the chance that the event will occur is greater than the chance that it will not occur. That's the logic. Risk over 1 minus risk. That is the odds. You will see if the risk ranges from 0 to 1, the odds will range from 0 to infinity. So let's look at the table you see beside. We try to tabulate a particular value of probability, which is risk, against the corresponding odds. If the probability is 0 or the risk is 0, the odd is 0 also. For example, if you say the probability is 0, then the probability that we don't happen me is 1. So you now say is 0 over 1. Anything 0 over anything is 0. So if the probability is 0, odd is 0. But when the probability, look at it, when the probability is 0.5, you know the probability ranges from 0 to 1. The halfway is 0.5. The corresponding odd is 1. For example, if you use the formula, we say all this risk over risk, 1 minus risk. Risk, let's say 0.5. 1 minus risk will be 0.5 also. That is 1 minus 0.5, 0.5. So odd will be 0.5 over 0.5, which is 1. So can you see now, when the risk is 0.5, the corresponding odd is 1. When the risk move to 1, it's 1. The odd is infinity. If you look at it, if you say risk is 1, odd will be 1 minus 1. And sorry, 1 minus risk. If the risk is 1, 1 minus 2 will be 1 minus 1, which is 0. So anything over 0 is infinity. So that is why when the risk move halfway, the corresponding odd move to 1. When the risk completes journey to 1, the corresponding odd go to infinity. So the value of risk is between 0 and 1. The value of odd between 0 and infinity. And that is why you can now see that the range of value of risk is limited. 0 to 1 is narrow. The odd is from 0 to infinity, it's wider. And that is why you can see the value of odd, can you see it can be big, 990 something, can be big, can be high. Whereas for odd to infinity, but for that's odd, the risk is limited between 0 and 1. That is why the people that gamble or that bet for uh, football, that do betting, they use odds rather than risk, because when they try to calculate the odds rather than the probability of different club winning. So if you they use risk, you may not find any much difference in the value of those risks when you calculate it for different club. You'll not be able to know which one has higher probability. But when they change it to odds, you will see the mark difference. You will see that one, the odds is higher, far higher than the other. You'll be able to know, okay, this one will likely win than the other. So those people that bet for football, which club win the football, they use odds rather than this, because it has higher range, wider range of value. Now, the other way, if you want to calculate risk from odds, is just to change the subject of the formula. Risk for risk equal to odd over 1 plus odd. So let's look at this diagram example below. Odd is probability of the event over 1 minus probability of event, P over 1 minus P. Or P odd is probability is odd over 1 plus odd. Can you see? Odd is P over risk over 1 minus risk, while risk is odd over 1 plus odd. So let's look at the diagram below. Let's see, look at the odd. You see, if you say probability of event happening, let's say there's a circle. Look at look at this circle now, a sector. Look at the circle of the cycle. Small sector, that is the probability of event happening, that red area. The probability of the event happening is that area all over the total circle. While the odd is that area, red area all over the remaining part. So when the disease is real, odd approximates risk. The value of odd is very close to risk. That is, when the disease is real, and if you say that small sector all over the remaining one, it's as much as saying that small sector all over the total. Because that small sector is tiny compared with the rest. So if you look at it, look at the value corresponding to that table again, the corresponding value of odd and risk. You see that as the probability is smaller, the value of the odd is close to that of the risk. Of course, when probability risk is 0, odd is 0. But as the odd risk becomes bigger, small than 0, then the odd becomes bigger than the risk, until when the risk get to 1, the odd get to infinity. So you see, you agree that when the prevalence of an attribute is real, the value of odd is the value of risk. So now this graph is just showing what I've just said. Now, do I want to, because there are some aspects of binary risk and odd and logic. There are some aspects I like to skip, because to me, when I do workshops, sometimes I go into town, I discover that when you are giving lecture, you don't need to go into too many things that make people to be confused. But the issue there is just for you to understand some fundamental things, to understand the difference between odd and risk, relative risk, and odd ratio. Let's just move. I will skip some of those things so that we won't bother you much with too much information, so that it will not result into information overload. Now, let's talk about relative risk and odd ratio. Because when you want to, most of the time, when you want to study disease, you want to compare, the only way you can say a particular thing is a risk factor for disease. We all know in study design, you must have an analytical design where you have at least you will actually look at the risk in a population. You look at the effect that particular risk, the factor, how does it influence existence or prevalence of the disease? How does it influence the disease in a group? Then you must be able to see another group that does not have the factor, compare the prevalence of the disease in that group. So it is when you compare the prevalence of the disease in a group that has the factor, you compare with the prevalence in a group that does not have the factor, before you can say that particular is a factor to the disease. Because it's not all the time. When we say this factor, it doesn't mean that if the attribute is present in the population, it will cause the disease, not all the time. So, for the fact that the attribute is not in the population does not mean the disease will not happen. Can you see now? But if that particular attribute contributes very well to the disease, occurrence of the disease, we expect the probability of having the disease in the population that has among the people that have the risk factor to be far, far higher than the probability of having the disease among the people that are not exposed to the factor. So the issue there now, probability of the disease in a population that is exposed compared with the probability of the disease in a population that is not exposed. So the best way to do the comparison is to divide, to really, okay, what is the prevalence or probability of disease in a group that have the exposure divided by the probability of the disease in a group that does not have the exposure. Because you want to know how many times the disease is likely to occur among the people that are exposed to a particular risk factor than among the people that are not exposed. So if you can establish the fact that among the people that are exposed, the disease is 5 times or 10 times more likely to happen, you can be said than among the people that are not exposed to the disease. You can say that that exposure is a contribution. So the logic behind this is division, to divide the risk among the exposed by the risk among the non-exposed. So the risk among the exposed, we always make it as the numerator, and the risk among the non-exposed. So that is what brought relative risk. Relative risk just means risk divided by risk. That is, risk among the people that are exposed relative to the people that are not exposed. How many times? When you compare with the people that are not exposed, the risk higher. That's why they call it relative risk. Another name for that relative risk is risk, because it's a ratio. A ratio is what you get when you divide two quantities of the same unit. So when you divide risk by risk, it's a ratio. So another name for it is risk ratio. In fact, that's what describes it better, risk ratio. But another way, the common one they say is relative risk. Risk among the exposed relative to risk among the non. Now, it's the same thing, the odds ratio. The odds, because if you look at what happened the other time when we compare risk and odds, risk is futuristic in the sense that when you say probability of something happening, you are just predicting before it happens. You may say probability of something happening is 0.6. It may not even happen. Even in some situations, you say it's 1. It may not happen. Well, it's just a prediction. You may say the probability of something happening is close to 0. It may still happen. Even some people may even say the probability is 0 and it may happen. So probability is more like something futuristic. But odds in the other way around is not like that. Odds, if you look at it, is calculated from probability. Is where something has happened that you calculate most of the time anyway, where you can calculate probably odds from a risk. But the issue there is in a situation where you cannot calculate risk, if the event has happened, now calculate odds. So the same thing, you compare the odds, we see explain it further, among the people, though this one is odd of the exposure among the people that have the disease, divided by the odd of exposure among the people that don't have the disease. It's still division also. So they call it odd ratio. That one is, I think, it means more. Also call it relative odd. Odd among a group relative to the other. But to me, what describes them better is the ratio, odd ratio, risk ratio. So over the years, people use relative risk, not risk ratio. And they say odd ratio, not relative odds. So odd ratio is used when the occurrence of an event, e.g., incident of a disease, cannot be calculated because it has already occurred in the past. Example, when you do, if your study design is case control study, where the case, that is, the people have already developed the disease, or it's cross-section analytical study. Cross-sectional study, both the exposure, you measure both exposure and the disease at the same time. That shows that the disease has already happened. So that's a cross-section. So although most statistical methods, such as logistic regression, that are employed to identify the predictor of our outcome by removing confounder, use odd ratio to measure strength of association. So you can even do, okay, for example, now you usually say, oh, for experimental study, you can calculate relative risk. For cohort study, you calculate relative, because at the start of your study, the event has not occurred in cohort study and experimental study. The desired effect you want to measure has not occurred at the beginning of your study. So in that, it is easy, you calculate the risk, you calculate the relative risk. So in that situation, you calculate relative risk because the thing has occurred. So, but in a situation where the event has occurred, case control, cross-sectional study, you cannot calculate risk. So in that case, you cannot calculate relative risk. You now use odd ratio because you can only calculate odd. You now use odd ratio as a proxy, because the real risk is the relative risk you are comparing, the risk. But odd is a proxy to risk. But what I'm saying that, what I'm saying, the last line, that number C, is that you can actually use odd ratio for any study, in the sense that when you are trying to do logistics, you want to remove confounder, the statistic you are using is odd ratio, not relative risk. Even in experimental design, you want to know factor, you want to run logistic regression, even in cohort study. So many examiners, they don't know this there, and sometimes somebody just no. He said this is a cross-sectional study, it's not case study, you cannot use odd ratio. Who told you that you cannot use odd ratio? Even in experimental design, you can come out with odd ratio. If you do logistic regression, it's odd ratio that will give you. So I think that one we'll talk about it later. Now, the situation anyway, this thing I'm just is what I've just said now. What situation around calculating risk and odd, relative risk odd ratio. It is when, if you are looking forward at the start of your study, the event has not occurred, you are starting with the risk factor. How many of you that have the risk factor develop, and how many of you that don't have the risk factor develop the disease? Yes, it's a prospective study. So all this clinical trial, the clinical trial may not be the disease you are mentioning, it may be outcome, it may be result, it may be whatever. So, but the issue is that the effect you want to measure is still visual at the beginning of your study. So, in that situation, you can calculate relative risk. But in a situation where the event of interest, it may not be disease, but has occurred. So both the exposure, of course, has occurred in the past, the events has occurred in the past. So we are talking about case control or even post-sectional design. In this situation, you cannot calculate risk, you calculate all ratio. Mind you, all the situation also where you can calculate all relative risk, you can calculate all ratio. It's only that in a situation, there are some situations you cannot calculate relative risk. It's just like if a professor, a consultant, will not come, is not around in the clinic, a junior person can cover. So, but it's not possible that a junior person that's supposed to be in clinic and say the professor is not around, professor is a guy will not cover for him. It's not possible. So that shows there are some situations that the guy cannot go to the clinic, but there are no situations that the junior cannot go to the clinic. During his own time, during the time of his guy, if his guy is not around, he can cover. So in this case now, odd ratio is the proxy, is the junior to relative risk. So you can even use it in any situation, but the relative risk always used in only certain situation. Now, the issue of calculating odd ratio and relative risk, you understand it better, or the logic behind it is using contingency table. And it's not just contingent, 2 by 2 contingency table. A 2 by 2 contingency, we are dealing with whatever the outcome and the exposure has been categorized into 2. And that's why they say that the epidemiologists has put everything into 2 by 2 table. Everything is in 2 by 2 table. Because to an epidemiologist, the outcome is either there or not there. The exposure is either there or not there. So the outcome is measured in 2 ways. There are 2 possible outcomes: dead or alive, treated, not treated. This or not is yes or no. Dr. Sebastian, the same thing, the exposure, either exposure. Look at example now. We are trying to say, okay, factors. We want to compare the prevalence or occurrence of the disease among the exposed and not exposed. The occurrence of the disease, which is the outcome, is either yes or no. Occur. This one has the disease, does it? So you divide the people into either the person has the disease or not. The exposure is whether the person is exposed or not. So when you bring them together in it, you usually put the outcome at the column, the exposure at the row. No exposure lead to outcome. Exposure at the row, at the column, the outcome. So look at this example of this table now. You have this factor now is along the row. Exposed, short status, exposed, not exposed. The outcome, event occur, yes or no. So this, you now see the way they designate the 4 cells are A, B, C, that as a result of intersection of those exposure and outcome. For example, the first cell, which is designated A, is those that are exposed that have the outcome. They were exposed, they developed the outcome. B were exposed, but they did not develop the outcome. C were not exposed, but developed the outcome. D were not exposed and did not develop the outcome. You will see A and D are concordant in the sense that exposed, develop, non-exposed did not develop. That is, they are concordant. But B and D are discordant. B is exposed, they are not discordant, is not developed. C not exposed but developed. You know, like somebody, yeah, if somebody say smoky lung cancer. Somebody smoke, eventually develop cancer. You know, say, oh, no, he actually smoked for long. He was a chain smoker because it justified that a chain smoker developed lung cancer. But what of somebody that is a chain smoker, B, did not develop lung cancer? The lung was okay. That is this color. What of C? He wasn't a chain smoker, but developed, he wasn't even smoking, but developed lung cancer. That is C. Of course, D did not smoke, did not develop cancer. So I'm just giving an example. So, and this designation is sacrosanct because it's A, B, C that way. Even in when we do for what do I call it, diagnostic test, it's the same thing, A, B, C. Those said A, B, C. Now let's look at the way it works. If you look at really, how do you understand relative risk from it? Relative risk is the risk among the exposed over the risk among the non-exposed. What is the risk among the exposed now? Exposed, A develop, A and B were exposed. Only A developed. Okay, maybe let me move to the next. If a table bring the total. Okay, I think rather than using that one, let's use real example to explain it relatively. It's an example. In a study, 500 smokers and 1,000 non-smokers were followed up for 10 years to see how many would develop lung cancer. Can you see? 100 and 500. 500 smokers, 1,000 non-smokers. If you see the total for smoking the exposure, yes, it's 500. Non-smoking is 1,000. If the 25 of the smokers and 5 of the non-smokers develop lung cancer, respectively, what is the relative risk of developing lung cancer following smoking? So you see, among the 500 that smoke, 25 develop lung cancer. That is the A. Can you see? Of course, the remaining 25 for 500, the people that didn't develop lung cancer were smoke for 475. That is the B. But the total is A plus B. The total is A plus B. Now, among the 1,000 that is not small, 5 develop lung cancer. Of course, the remaining one, 1,000 minus 5, which is 995, did not develop cancer. So that 5 is the C. 995 is the D. So what is the risk for you to calculate risk ratio or relative risk now, which is the risk among the exposed, that is the risk of lung cancer among the years people that smoke, divided by the risk of lung cancer among the people that did not smoke. So the risk among the people that smoke is 25 out of 500. 25 divided by 500. That's why they say A is 25. Divided by A plus B is 25 plus 49475 is what gives you 500. That's why they say A over A plus B. Because that 500 is A plus B. So then the risk among the people that do not smoke will be 5 over 1,000. 5 is A, 1,000 is A, 5 is C, rather. 1,000 is C plus D. So when you say 25 over 500 divided by 5 over 1,000, you see we change 25 over 500. If you want to change the division, the other division, to times, it become, you swap the denominator and numerator, it become 1000 over 5. If you solve it, it gives you 10. So what it's telling you is that the relative risk is 10. It's 10, that is the risk. What, because you divided the risk among the exposed, the people that smoke, by the risk among the people that, at least the risk here is the proportion, probability, or prevalence of the disease among the exposed, among the smokers, 25 over 500. And the prevalence among the people that didn't smoke is 5 over 1000. When you divide 25 over 500 by 5 over 1000, it gives you 10. It shows that the risk of lung cancer is 10 times bigger among smoker and non-smoker. That is the relative risk of death. For the same event, where you can calculate the odds ratio, computer or mathematics is garbage in, garbage out. Is you that for this situation now, it's a cohort study. So calculate relatively. You are not calculating odds ratio. But the data says you can, that's odds ratio. You can calculate odds ratio from it. So let's move to the next example. We'll not talk about it. We'll come back to this. So when we run it, I will come back to explain something. That is an example for relative risk. That's why the formula is relative risk is A all over A plus B, everything all over C all over C plus D. Let's look at second example, which we use to explain the odds ratio. Of 200 patients treated in a hospital, when you say patient, that person, they have the disease. 50 have lung cancer. Of these patients, 45 are smokers. Of the remaining 150 patients, 60 are smokers. What is the odds ratio for smoking? So what is it now? 50 have lung cancer. Of 200 patients treated in hospital, 50 have lung cancer. Look at the table now. 200 is the grand total. So along the column is lung cancer. How many have lung cancer? 50. So of course, if 50 have lung cancer, the remaining 150 did not have lung cancer. 150, no lung cancer. So we now say, out of the 50 that have lung cancer, 45 smoke. They have history. If you look at this one now, they started with disease first. You cannot calculate. Actually, it doesn't make sense to calculate relative risk here because the disease has occurred. They are just telling us that, okay, after they know that these 50 people, they took history and I found that 45 of the 50 smoke. Among the 150 that do not have lung cancer, 60 of them smoke also. So now, if 45 out of the 50 smoke, that should have the remaining 5 did not smoke. If 60 out of 150 smoke, the remaining 19 did not smoke. So it's still the same. 45 is A, 60 is B, 5 is C, 90 is D. Now, in the real sense, if you want to know what is the, we know that HOD, if you say what is the HOD of smoking along the people that have lung cancer, the odds of smoking is 45 over 5. How do I know? We say that risk odd is risk over 1 minus risk. So the risk here will be 45 over 50. 1 minus risk will be 5 over 50. 45 over 50 divided by 5 over 50 is the same thing as 45/5. The same thing with the odd of smoking. Among the people that didn't have lung cancer, it will be 60/90. So if 45/50/5 rather is the odd of smoking among the people with lung cancer, and 60/90 is the odd of not smoking. So the odd ratio will be 45/5 divided by 60/90. So when you change, it becomes 45/5 times 90/60. But if you look at it, some people just say, why not cross? Just say 45 times 90 divided by, that's A times 90 is A, D is in 45A, 90 is D. So 45 times 90 is AD over 60 is B, 5 is C over BC. That is odd ratio. So the odd ratio here is 13.5. It means that the people that have lung cancer, they are 13 times more likely to smoke. Is there another way? Is another way, cheap way of saying that smokers are 13.5 times more likely to have lung cancer. Can you see now? It's like walking from answer to question. It's not direct like the relative risk, but this one, what you actually measure is the odd of smoking. You calculated the odd of smoking among lung cancer. It's different from the other one where you calculate the prevalence of the disease, the risk of the disease among smokers divided by the risk of the non-smoker. But here now is the odd of smoking exposure among the people that have the disease divided by the odd of exposure among the people that didn't have the disease. There is a proxy to measure the risk of the disease. So we have already said relative risk is proxy to odd ratio. Just like what happens for this thing also, you can as well calculate relative risk for the same data, assuming that is core study or experimental study. You can calculate. That's why when you are running analysis, it's not the computer what computer bring out. You must be able to know what you want, go for it. Because the computer does not know statistics. Whatever they program those things there, just give it. It's you that understands statistics. It's you that will use the computer to achieve what you want to achieve. Now, there is a way, the other one, I don't want to bother you, the confidence interval. So apart from, look at the first one, when we run it with SPSS, you give a look at the table, you give yours, you see, look at the, for core lung cancer, that is the relative risk. The relative risk is 10. And the relative risk is 10. The odd ratio for that particular one, which I didn't, which you can, is 10.47 for that first data. Look at it, show us that first one is the odd ratio, 10.47. The relative risk is 10. Then it will give you relative risk 95% confidence interval. Solving that one with N is a little bit rigorous. So I don't, but just for you to, we have already talked about the confidence interval, the concept. What confidence time just means that, okay, this is the relative risk. This how many times. And from your sample, you have calculated how many times the people that smoke are more likely to have lung cancer than people that don't smoke. But in the population, because that one is from a sample you collected, in the real population, because in as much that you have not taken all the population element into consideration, the real relative risk in the population is a parameter. The relative risk in the sample is a statistic, but for the population itself is a parameter. So in that situation, you want to know how many, what is the range of value in the population within which you can find the population value. You give us for this relative risk of 10, give us 3.85 to 25.965. So how do we know if it's significant? The range of value must not cross 1. If the range of value include 1, the only thing that can make it to include that is if the lower value is 0 point something and the upper value is anything greater than 1. You know, when you say the range of value is 0.3 to 2.4, it means that it can be any value from 0.3 to 2.4, including 1, because for you to move from 0.3, you have to cross 1 to move on to 2.4. So once the range of value crosses 1, it means that 1 is one of the possible values in the population. And you know that the relative risk of 1 is like, say, the risk of the disease among the exposed is equal to the risk of the disease among the non-exposed. Because if the numerator, it is only when the numerator is equal to the denominator that you get 1. When you divide two things, it is only when the numerator and denominator are the same value that you get 1. It means that the risk among the exposed, which is the numerator, is the same thing as the risk among the not exposed, which is the denominator. So if the risk is the same, actually there's no association. That's so that particular exposure does not cause the disease. It's not a risk factor. It means there's no association between that factor and the causation of the disease. That is why, when we already know that the relative risk or odd ratio of 1 means there's no association. So when the confidence interval crosses and including 1, it's not significant because it can as well be 1. That's what it means. You are telling us that the range of value in the population is anything between this and this. And once it includes 1, no. So like this one, it does not include 1. You know that. The same thing, you come to the other one, the same thing. Look at the odd ratio for that data, 30.5, and the relative risk is 8.143. You know, look at the relative risk here, 8.143. So it's the same interpretation. Even though relative risk is a proxy to odd ratio, it's the same interpretation. So to interpret it further, if the relative risk or odd ratio is close to 1, or is 1 or close to 1, so there's no association between exposure and development of the disease. But a relative risk or odd ratio greater than 1 indicate a positive association between the exposure and the disease. Because if it is greater than 1, that shows that the exposure is higher or the disease is higher among the exposed. Because the disease among the exposed is what you use as numerator. The one among the non-exposed is what you use as denominator. So if it is greater than 1, it means that numerator is greater than 1. It's greater than the denominator. That shows that the prevalence, the burden of the disease is higher among the exposed. But if relative risk or odd ratio is less than 1, it means the exposure is associated with the less disease and may be protective. Imagine when you calculate and you now get 0 point something, because it is when the numerator is smaller than the denominator. When you divide, you get 0 point something, and that is less than 1. So when you get anything 0 point something, it means that it is less than 1. So it means that the burden of the disease among the exposed is smaller, because that's when you use as numerator, than the burden of the disease or the risk of it among the non-exposed, which is denominator. That shows that even the people that are not exposed, they have more disease than the people you think are exposed. So that thing you call a factor of the disease actually not a factor. Maybe it's a protective factor in this case. It's not causing disease. That factor is a protective one. That is when the odds ratio relatively is less than 1. If the relative is often reported as a single number followed by confidence interval. That's what I've said before. In parentheses, in bracket. If the range of confidence interval include 1, then the result is not statistically significant. Look at this diagram. You see, look at that line, that vertical line. That's the value of 1, either relative risk. So when the relative risk, when the exposure, reduce exposure, the relative risk will be less than 1. That is, if the exposure reduce the disease, that is, so the relative risk will be less than 1. But look at the other side. If there's increased risk with the exposure, the relative is greater than 1. When the relative risk is 1, it means neither increase or decrease in the risk with exposure. That should that thing does not even change anything, does not protect, it does not cause it, as the relative is equal to 1. So the interpretation, I already said, when look at the confidence interval, if the confidence interval is something, look at on the left side, less than 1, on the right side, greater than 1. When the confidence interval ranges from both upper and lower, they are less than 1, is significant. If the lower is less than 1 and upper is greater than 1, in these two middle scenarios, that shows that it's insignificant because the range of value of that confidence interval has included 1. But if both the upper and the lower value are greater than 1, it means that it's significant also. So what is the difference between the significant in a situation where both of them, lower and upper, are less than 1, and when it is both lower and upper are greater than 1? Difference. When both upper and lower are greater than 1, it means that that factor caused the disease, because it means that the relative risk you are calculating or odds ratio is actually greater than 1. And the confidence interval, everything greater than 1. But if it means that that particular risk is causing the disease, the exposure is causing the outcome. But if it's the other way around, it means that the exposure is protective. It means that the relative risk is actually less than 1. And both the lower and upper limit, of course, less than 1. In that situation, is significant. But that particular exposure is protective. So I don't know the time, because there are some other things. Should we just stop here? I should just explain there are some other thing, important thing I want to explain concerning these relative risks and odds ratio, the relationship between them. Still, do like a 3 slide or 4. Maybe we should stop here. I will continue from here in the next lecture, so that, because I believe you have questions this time. Any question? I will surprised if there is no question. This is so simple. Straightforward. Any question? No question. Okay, there's no question.